Welcome back, ladies and gentlemen. So today we're going to be finishing up our unit on foundational geometry with angle addition theorem. So let's take a look. Okay. An angle. Now, some key vocab for you guys. An angle consists of two different rays that have the same initial point. So what we're looking at here is you have yourself an initial point right here, and you have two rays jumping off of it. You guys have seen angles before. And today we're going to discuss how many different types of angles there are and so on and so forth. The rays are the side of the angle. So these two things are your rays. They're your sides. Okay. And then the initial point, now this is kind of important. This is called your vertex. You will hear me drop this a lot. Vertex is that middle point. Okay. Just a key vocab word right there for you. Now, these types of angles you've all seen before. In fact, we've been talking about them in class already. An acute angle is an angle that is between 0 and 90. Okay? So I put a little X in here showing that it can be anything from 1 degree all the way to 89 degrees. You get the idea. It is not 0. It is not 90. Okay? That's an acute angle. Obtuse is when you are talking about an angle that is greater than 90 but less than 180. Again, notice it's just less than, or greater than, less than. It's not equaling 90, it's not equaling 180, okay? Because 90 and 180 are special angles. A right angle is exactly 90 degrees, okay? So it's a corner. Anytime you have a corner angle, that's a right angle. And then a straight angle is 180 degrees, which is super important, which we talk about a whole heck of a lot. When two angles add up to 180, we call them supplementary angles, or if they're side by side and adjacent, we call them linear pairs. Now, as with all of geometry, it's a lot of naming things and correct notation. For here, we have 3 points, P, R, Q. If I was going to name this angle, we use a little angle symbol. And we see angle P, R, Q. The R is your vertex. That must go in the middle, right? That's important. You could have named this angle Q, R, P, but the R has to be in the middle, okay? Very important. Now, if I come down a little bit, here we go, some practice problems. A lawn is watered by a sprinkler that has two fixed spray heads at each water in a fan shape. The angle that determines each of the fan shapes is 120 degrees. The shaded area in the diagram shows where the two fan shapes overlap. Find the measure of angle 2. Okay, so the whole thing is 120 degrees. Each of these is 30, and I want to try and find the one in the middle. So what I can do is subtract 30, get 90, and I'm going to subtract 30 again and get 60. So this angle in here is 60. Pardon me. I can add these three together. If I add them, 30 plus 60 plus 30, I get 120, all as well. Okay? So good stuff. Now, protractor postulate. I'm hoping you guys have read a protractor before. I know it's probably been a little while. It's okay. You're going to notice you have two sets of numbers. I know it's really tiny on here, but hopefully you can see your paper. From 0 to 180, and then over here it goes from 0 to 180. So consider a point A on one side of the line OB. The rays of the form ray OA, they can be matched 1-to-1 with the real numbers from 0 to 180 degrees. The measure of angle AOB is equal to the difference between the real numbers of ray OA and ray OB. What they're saying here is you put the side of your protractor on the side of your angle, okay? And you check this out all the way over and you follow it. Now here it says it can either be 68 degrees, okay, or 102 degrees, right? Or I'm sorry, 112 degrees. What you have to use is the correct angle notation, all right? So here is going to be 112, all is good, all right? If I go to the back here, okay, angle addition postulate. This is very similar to your segment addition postulate. Okay, so it's almost the exact same thing when we talk about like the two rulers. This ruler plus this ruler equals the big ruler. Well, it's the same thing with angles. If P is in the interior of angle RST, then, okay, so I can write in here the measure of angle RST RSP plus the measure angle PST equals the measure of angle RST. Okay, so the two small angles have to give you the big angle. Alright? So classifying an angle in a coordinate plane. So here we've got a bunch of different pictures drawn. We have points plotted A, B, C, all the way through F. And they're asking us for angle AFD. So we can take a highlighter out if we need to, whatever. Here's AFD. Pardon me. AFD is obtuse. It's past 90 degrees. So when I say 90 degrees, I mean here's a corner. It's bigger than that. So that is an obtuse angle. Okay? Now, if I asked you for AFE, right, notice that AFE here. So for AFE, we were looking at AFE. So corner would be going this way. It's a little less than our corner, which is less than 90 degrees. So that means this is going to be acute. All right. Angle BFD. So BFD, if I follow those 3 points straight down, that's a straight line. There we go. Very nice. And lastly, BFC. BFC is that corner that we've been talking about. That's our right angle. Right. Okay. The last few problems here, it says use the angle addition postulate to find the measure of the angle. So the measure of angle HLK. So important to kind of point out, I'm trying to find this particular angle, okay, the small one. Now, this is acute. So when I get my answer should definitely be less than 90 degrees, okay? So if I take a look, here is a right angle. I know I can say 90 minus 30, okay, which gives me 60 degrees. So, boom, my measure of angle HLK, 60 degrees. Good stuff. As far as for part B, the measure of angle ABC, again, I'm putting the entire thing together here. So it's two adjacent angles, ABD and angle DBC. I'm doing 50 plus 80, 130 degrees. And again, important to note for all of these, when you're doing angles, we're talking about degrees. Make sure you have that in there as well. All right. Finally, this last problem is a little trickier. I just jumped all over the place, didn't it? Ooh, that was really weird. Find the measure of each angle given the following, and they tell you that the measure of angle ABC is 130. Now, this is very different than what we talked about the other day with bisecting. Bisecting is when it cuts in half. Here they're telling you the big angle. The big angle is 130 degrees. So, what you guys can do, all right, is I can go ahead and make up an equation. I know 2x plus 2 plus 3 parentheses x plus 1 equals 130 degrees. Right? Small plus small equals the big one. That's all we're talking about here. So, clean this up. 2x plus 2, I can distribute that 3 in. 3x plus 3 equals 180 degrees. My computer's acting very funny. I apologize for that. I have no idea why. It's freaking me out. And I just said 180 there too because I was caught off guard by the jumping around. My apologies. 130. I know you're going to call me out on that one, so thank you. Combining like terms, 2x and 3x gives me 5x. 2 and 3 is 5. And why am I doing that? Because it's on the same side of the equation. If I subtract 5 over, 5x equals 125. Okay? And then I can divide both sides by 5. I'm left with x equals 25. Now here's the thing, please be careful. It says find the measure of each angle. So I found x equals 25. That's awesome. We did a great job. High five. But then you got to make sure you take this and plug it back in. So we're looking 2 times 25 plus 2. 2 times 25 is 50, plus 2 is 52 degrees. And then over here, if I plug in 25, it's looking like 3 times 25 plus 1. So 3 times 26 is 78 degrees. Okay? So, good stuff. Talking about angles. Remember your degrees, okay? this wraps up our unit on foundational geometry. So any questions, please feel free to ask. And as always, good luck. We're all counting on you.